Hello. I just wanted to show how to do this Leetcode medium problem. It's called longest absolute file path. I think it's relatively easy, so let's get into it. So basically what we're given is a string representation of a file system. So that would be a sort of directory hierarchy that you can see kind of diagrammed in this picture. Obviously not this exact one, but this is just one example. And you're going to have some root directory, and that root directory is going to have some number of subdirectories, right? Those subdirectories in terms might have subdirectories, but importantly, we're also going to have files, and files, as it says somewhere in this description, are marked as files because they have a period in them. And you can see that we're actually given a raw string as our file. This is how we get our representation of the file system. It's just as a raw string, where basically indentation is how the hierarchy is represented. So you can see in this diagram right here, our root is dir. We tab in 1 to show that subdir1 is a subdirectory of the next highest thing, dir. And then in turn we have something tabbed in twice to represent there's one more than subdir, and it shows that it is inside subdir1. And you can see that this can go on for some time, that we're going to have two more double tabbed items, and then it goes back to one tab to show that it's just a subdirectory of dir in the root. And then you have subdir2, which is double tabbed in, so it's now a subdirectory of subdir2. And you have file2.ext. Great. So that's simple enough. And this is all demarcated by different tabbing levels. That is how we are given the file system, or I guess you could say the file hierarchy. And basically, you can think of any given file, which is any line that's file path name has a period in it. For example, file1.exe, file2.exe. We can think about that in terms of an absolute path. So, for example, that would be dir, subdir2, subdir2, file2.exe with just not tabs, but slashes separating them. And that will create an absolute path name. And the question is, given an entire file system in this kind of string format, what file has the longest path name? So that's the problem. You can see that we're given a few examples here. dir, subdir1, subdir2, file.ext. File.ext is obviously the longest, the only file. And then we have two files right here, file1.exe, file2.ext. Obviously, dir, subdir2, subdir2, file2.ext is the longest. We have another one here which just has a single folder directory named A. There are no files, so the answer is 0. Okay, so how will we go about addressing this? How do we go about tackling it? The first thing we're going to do is we're going to look at the information that's given to us. We're going to look at this example, right? So it should be obvious at this point that how we're going to actually calculate the length of any given file is we're going to keep track of the overhead directory structure above it. So for example, for file1.ext, we're going to need to know that its parent is called subdir1 and that the parent before it is called dir. Similarly, for file2.ext, we need to know all of its ancestor directories. So the question is, how do we figure that out just simply based off of this tabbing level for each file? So you can see, for example, that we go dir subdir1, and subdir1 tabs in, so it's one more. And then file1.ext tabs in once more than that, so it must be under that. And then we process that and do something with it, and then we process subdir1, we do something with that, and then you can see that we actually drop down a tabbing level, and we get subdir2. So at this point, subdir1 is no longer relevant, it has to be discarded. So you can see that a backtab, or not necessarily backtab, but a loss of a tabbing level means a loss of a directory, right? And it's in fact the most recent directory that we added. So, for example, if tabbing in adds to this overhead directory structure that we're keeping track of so that when we encounter a file that we can actually figure out its absolute path, then tabbing down a level than what was previous will actually lose a directory level. So that is going to be a stack data structure, right? First in, first out, where you can think of the stack building up from previous directories that we've seen before we get to any given line. And then the popping operation will occur when we tab down, right? If we get to subdir2 and we see that it's one tab less than what was at subdir1 a minute ago, then we know that subdir1 is no longer being expressed here, and that we're actually under dir subdir2. So anyway, that's basically half the battle, keeping track of the different what the actual directory path is to a given file. That's half the battle, right? And if you know that, then it's pretty easy to construct what the actual length of the file name is, right? You can just simply construct it from what is actually inside the stack and then take the length of it and compare it to what the greatest length we've seen so far and then export it. So very high level, I'm going to kind of give some pseudocode here. The very high level is that one, we're going to parse the string given one line at a time, not one line at a time. Okay, we are going to analyze tabbing level to figure out how many directory levels, figure out what directory level we're at, and if we've lost any. And then at this point, right after step 2, then our stack data structure should represent accurately what directory level we're currently at when we process any given line, right? And then step 3 will be, well, if we're at a directory, then we're just going to add it to the stack. And if we're at a file can't have children, then we'll just add we'll look at the directory structure that's encoded in our stack data structure. We'll use it to calculate the length of the absolute path that we're currently at, and then we'll compare that against the greatest path length seen, and then we'll keep track of the max of the two. The absolute greatest seen. And that's basically our pseudocode. So just one other thing we should be thinking about is maybe we can even think of an example here where we have, I'll pull in this example on the left. dir subdir1, file1.ext, subdir1, and then subdir2. right? So we process line 29 and dir gets added to our stack. We process line 30, we see this tabbed in 1, so subdir 1 is added to our stack. We get to this line, we see that we're in 2, so one more than the previous, and file1.ext is now our current file, so we can take all of this information that's in our stack and we combine it with file1.ext to create a file name. So dir subdir1 file1.ext. And then we can run step 4 with this where we can calculate the length and then compare it to the greatest scene and so forth. And then that's great. And then we analyze subdir1. We add it to the stack briefly. We see that it has no children, so we pop it out. Actually, let's think about this. We can see that we actually not only does it not have any children, but that the that this tabbing level actually goes down. So we see that in our next file we have subdir2, which is only at 1 tabbing level, right? And we see that we actually, what we want this list to transform into is dir subdir2, right? And we can see that the tabbing level is 1, right? And the length of our current directory hierarchy is 3. So what we do is we take off 2 of these because it's the difference between the length of the stack and the next item we see. And this might be kind of, I guess, a strange kind of way to think about it. It might not be immediately obvious to think about it that way. But in other words, the current length of the stack represents basically how many tabs we should be in for us to see a new file underneath this latest directory. So for example, this should be, tab, 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 if I had this Unicode character, right? If we had something under subdir1, right, there will be 3 tabs here. But instead there's 1, right? So we know that we've actually gone back 2 levels of the directory hierarchy. So therefore, we need to pop out 2 of the current items in the stack. So that's kind of the way you have to conceptualize this problem. I probably went a little fast in terms of explaining how to do it, but that's how you do it. So I'm just going to go through and actually talk to you about how to code this. So we're going to import collections deck, which I already did. And we're going to create a descriptive variable name. We're going to say something like, path stack, I guess you could say, even though that this is going to represent the current directory path that we have. I'll even annotate it as such. Full directory path we are currently at. We're going to keep track of a variable that represents our best. So best path name length equals 0. Now we're going to iterate basically through each of these lines that we see in this example right here. We know that we want to process each of these names 1 line at a time. So we're going to split our input by new line. By the way, input is not a good variable name. in Python. One, because it's a function name input with this, and also because it's not descriptive. Anyway, so now we know we have to think about, before we even type this loop, what are we getting out of every iteration of it? Well, we're getting a unformatted file name. I won't say, it's not necessarily a file, it could be a directory. So we'll say, we'll just say file name, even though it might not be a file. I wish I could think of something better right now, but so we'll say for unformatted file name in input.split. And I'm going to even comment right here what I could expect unformatted file name to look like. So it could look like dir, it could look like tab T subdir1. It could look like, tab T subdir2, etc. Notice how I'm taking, in this annotation, I'm directly referencing what is in the example, so that there's a one-to-one correspondence between my comment and the example. Okay, now what we need to do, as we discussed before, we need to figure out how many tabs are at the beginning of this unformatted file name, and excuse me, and then we can use that to modify the current path stack. So we're going to say num tabs equals 0 while unformatted file name num tabs equals a tab num tabs plus equals 1. So this is just a very sort of fancy kind of way of calculating the number of tabs in that precedes whatever this unformatted file name is. You'd say, and I'm going to annotate that that's exactly what this code is doing. You'd say find the index. You can even say find the index of the first non-tab character in file name. Also, we're calculating obviously the number of tabs. Get number of tabs prefixed to file name. Okay, and we also know that the file name, quote unquote file name, even though it could be a directory, equals unformatted file name, and then num tabs and everything after it. So now we have our first, so for example, that might be subdir1. I'll even comment that. Dir file1.exe at set. So we're always keeping in mind what file name could be. Okay, and now the kind of tricky part that I was talking about earlier with the different levels of tabbing and what they tell us. But basically, in a nutshell, we know that while the length of path stack is greater than the number of tabs we've seen, then we're just going to pop the stack. Okay, great. So at this point, we know the number, we basically know everything that we need to know about file name in order, in the case that it's a file, to make a calculation on it. Path stack is corrected, and it accurately reflects where in the directory hierarchy we are. So now we can just get to processing it. So I'm actually going to write that as a comment to remind myself conceptually as to what this code should be doing. going to say at this point, path stack represents the true location of this file in the hierarchy. E.g. file1.ext, then path stack is going to equal, dir subdir1. So I'm giving an actual concrete example of what the different variables might look like at this point in time. So now we're going to discriminate based off of whether file name is actually a file or if it's a directory. So, and this problem specifies that all files just have a period in them. So we'll do if file name, if period in file name. You could also do, I think, file name that contains period, but it's all the same thing. And we will do something for that. I think that the other case, else direct, this is a directory, then we'll just append it to the current stack. But if it's a file, in that case, we know that this is a file, and we know that we have the path stack that represents it. So we're going to go all the way up and figure out what the absolute path is. We can figure out the absolute path now. So now we're going to construct the new path name from this. So the best way to think about this is that this is, I guess, kind of the only tricky part, is that we know that file name, whatever file name should be, should basically be the entire path stack joined by slashes, and then followed by, at the end, slash, and then the file name. There's a very minor exception that if the file is at the very root of the directory, then we don't have any prefix slash, we just have the file name. So this is how we do that in fstring. We do an fstring, and first we're going to do the stack joined. So we're going to do, I guess we can do this. Okay. Slash dot join path stack. Okay. So that will be, that will be, the first part will be like dir slash subdir1, etc. But no suffix slash, so to speak. And then we're going to add a suffix slash only if path stack actually has contents. So we'll do, we could do something like no string if not, we could do if not path stack, else slash, and then just the file name. And that's the new path name. And now it's just as simple as saying, best path name length equals max of best path name length and the length of this new path name. And that's basically it. And when we go to return best path name length, I think this should work. And I guess we'll try to run it right now. I had a solution earlier that was very similar that ran. So I'm not sure if this is 100% bug-free, but we'll see. Okay, so it works in this case. And you can see it's an accepted solution. So yeah, I'll post the source code and I'll post these notes right here, pseudocode, in the description of this video. But yeah, so anyway, so let's kind of discuss kind of lessons that you can glean from this. I think the first thing is that I obviously made a point out of being extremely organized with the code. I spent a lot of time commenting and so forth. I tried using very descriptive variable names. One thing I regret is not figuring out a better name for unformatted file name, because file name could be a directory. If there's some sort of, technically in Linux, directories are files. So it's not, I guess, technically wrong, but there should be something in this file name that emphasizes that it's not necessarily a file in the context of this problem. It could be a directory. That's one thing that could be improved. But otherwise, I really try to make a point here of alluding to the different, elements of this example. You can see that we spent the time thinking about this tabbing level and what that implied for the data structure surrounding the current path, directory path hierarchy. And that's kind of the most important thing, right? Is that we're keeping track of that. And you can see that once that's done, then we can kind of create a conceptual model of the problem and have path stack represent the actual level that we're at. So this is kind of like almost like the halfway point in the code. Everything up to here, what we were trying to figure out how we can take the new information of unformatted file name, look at what's currently in path stack and look at the tabs and use that to format and to correct path stack given the new tabbing information. And once we got that done, we're then going to use that information to construct a path name and then use that as the, go with the best path name and so forth. And then we add in the case that it's a directory, we add the directory name. So you can think of that as kind of being a core concept, that we're keeping track of the directory hierarchy as we go through the problem. And we're thinking about this path stack as somehow representing where we are in the problem, and that the tabs that we see preceding an unformatted file name will actually modify this path stack. But once we do that, then it's as simple as just constructing what the path name is and then keeping track of information and adding in new directories into the path stack. And that's basically it. Again, we did some stuff with pseudocode, and we showed how, having sort of a sober breakdown of the problem was helpful for constructing our actual algorithm. So, that's basically it. Let me know if you have any questions. I'll try responding in the comments. But hope you like. If you have any other problems I'm going to go over, let me know. So, yeah.